This question comes from Sarah, who asks, if the Earth were somehow instantly flattened into a disk, what would actually happen? The first thing to know is that the answer arrives almost immediately, and it isn't interesting. It's just catastrophic. But let's slow it down. The moment the Earth flattened, gravity would be the one doing all the talking. Here's the thing about gravity that the question runs straight into. Gravity doesn't care what shape you are, it pulls toward the center of mass. On a sphere, that center is right in the middle, underneath your feet wherever you stand, which is why down feels the same in Tokyo and in Sao Paulo. But on a disk, the center of mass is the center of the disk, roughly where the North Pole sits in the flat Earth models you may have seen online. That means gravity would only point straight down at one spot on the entire planet. The further you stood from that central point, the more down would tilt sideways, pulling you toward the North Pole like you were standing on the inside wall of an enormous bowl. According to James Davis, a geophysicist at Columbia University's Lamont Doherty Earth Observatory, all the world's oceans would immediately begin flowing toward that center, piling up in a vast, bulging mass of water over the Arctic, while the edges of the disk dried out completely. Trees, already growing perpendicular to local gravity, would now grow at a diagonal. Rain would fall sideways. The further you lived from the center, the more the entire world would feel tilted, because it would be. But we haven't even gotten to the main problem yet. A disk-shaped Earth wouldn't stay a disk. In the 1850s, the mathematician James Clerk Maxwell, the same Maxwell who later unified electricity and magnetism, was working on Saturn's rings, and showed mathematically that a solid disk-shaped planetary body is not a stable configuration. His math correctly predicted that Saturn's rings are made of countless small, separate particles, not a solid sheet, because a solid sheet of that scale would collapse under gravity. The same logic applies here. The rock and iron that make up the Earth would behave, under the pressure of planetary-scale gravity, less like stone and more like an extraordinarily slow fluid. Gravity pulls equally from all sides. A sphere is the shape that satisfies all those pulls simultaneously, and any deviation from a sphere becomes, at planetary scale, a stress that the material cannot hold. David Stevenson, a planetary scientist at Caltech, has pointed out that to actually spin matter into a disk shape, you'd have to rotate it so fast that it would tear itself apart. Flattening a planet any other way would require, as one summary put it, a galactic panini press. Within a few hours of the flattening, that pressure would win. The disk would begin collapsing back toward a sphere. This wouldn't be a gentle settling. The energy stored in the deformed shape of a planet is roughly comparable to what you'd get from detonating the entire Earth's mass in high explosives. The collapse would be a global catastrophic event, volcanic in scale, at every point on the surface simultaneously, with the rock behaving like a fluid as it redistributed itself. No structure, geological or human, would survive the process. So the honest answer to Sarah's question is that a flat Earth would last a few hours, and those hours would not be pleasant. There is something worth sitting with here, though. The reason Earth is a sphere isn't because of some cosmic preference for spheres. It's the direct, unavoidable result of gravity pulling matter toward a common center from every direction at once. Every planet, every moon, every large body in the solar system above a certain size becomes a sphere for exactly this reason. The threshold, roughly 400 to 600 kilometers across, depending on the material, is called the limit of hydrostatic equilibrium. Below that size, rocks are strong enough to resist their own gravity, which is why asteroids can be lumpy and irregular. Above it, gravity always wins. The Earth is round not in spite of the forces acting on it, but because of them. A flat Earth isn't just wrong about the shape. It requires gravity, the most universal force in the cosmos, to simply not work, which, to be fair, does explain a lot about the belief system.